Now the quadratic formula, negative b plus or minus the square root of b squared minus 4ac over 2a, we have learned will allow us to find the roots, rational, irrational, and complex, of a quadratic equation. But that portion that is under the square root, the b squared minus 4ac, is something called the discriminant. And we can use the value of the discriminant to help us describe what type of roots a quadratic equation may have. Now, if the discriminant is greater than 0 and is also a perfect square, then we're going to have two rational roots. If the discriminant is greater than 0 but not a perfect square, we're going to have two irrational roots. If the discriminant is equal to 0, we're going to have one real rational root. And if the discriminant is less than 0, we're going to have two complex roots. Complex roots are always going to come in pair. So here we're asked to find the value of the discriminant for each quadratic equation, and then describe the number and type of roots for the equation. Well, our first one, we got negative 5x squared plus 8 minus 1. And so let's find what the value of the discriminant is. Well, we'd have 8 squared minus 4 times a, which is negative 5, times 1, no, negative 1 times negative 1. So 8 squared is 64. And then negative 4 times negative 5 is positive 20, times negative 1 is going to be negative 20. And so the discriminant is going to be 44. Well, 44 is not a perfect square, and so but it's greater than 0, obviously. And so therefore, we're going to have two irrational roots. All right, so let's go over again what the discriminant can tell us. If the discriminant is greater than 0, and if it's a perfect square, then we're going to have two real roots. If the discriminant is greater than 0 but not a perfect square, we're going to have two irrational roots. If the discriminant is equal to 0, we're going to have one real rational root. And if the discriminant is less than 0, we're going to have two complex roots. Now we have a second equation, but it's not written in standard form. We got negative 7x plus 15x squared minus 4 equals 0. Well, let's first write this in standard form. 15x squared minus 7x minus 4 equals 0. And now let's determine the discriminant. So we've got negative 7 squared minus 4 times 15 times negative 4. And so there's our discriminant. Well, negative 7 squared is 49. And negative 4 times 15 is negative 60. And negative 60 times 4 is negative 60 times negative 60 times negative 4 is what? Positive 240. And that equals 289. And you know what? I think 289 is a perfect square. Let's see. It is, because 289 equals 17 squared. So since it is a perfect square, we can say that we've got two rational roots. Shazam. Well, once again, okay, if the discriminant is greater than 0, and if it's a perfect square, we're going to have two rational roots. If the discriminant is greater than 0, but not a perfect square, we're going to have two irrational roots. If the discriminant is equal to 0, we got one real root. And if the discriminant is less than 0, we got two complex roots, using the discriminant to describe the roots of a quadratic equation.